For 11.7, we're going to learn how to write Lewis structures for molecules with multiple bonds. A single bond isn't the only thing that we can use to draw Lewis structures, so we have to know when a multiple bond is appropriate and how we come to that conclusion using Lewis structures. In this case, we want to write the Lewis structure for CO2. So we want to start by identifying the number of electrons that they contribute to the overall compound. Carbon is in column 4, it contributes 4. Oxygen is in column 6, it contributes 6, and there are 2 of them. This gives me a total of 16. Now we're going to put the oxygens around the outside because we always put the more electronegative element on the outside of the compound. And then we're going to bond them. So remember, each of these bonds contains 2 electrons. So 2 electrons times 2 bonds is going to subtract 4 from the total. This leaves us with 12 left over. We're going to start by putting them around the oxygen. So there, I've used all of my 12 electrons. But the problem here is that carbon does not have an octet. Carbon only has access to 4 electrons. So we've got to take one of these pairs and swing them down to form a double bond. Oxygen, in each case, still has its octet, but carbon still does not have its octet. It only has access to 6 electrons. So, does this work? No, because carbon's octet rule is not satisfied. So we need to swing up another pair. And when we do this, carbon now has access to all 8 electrons, and each oxygen also has access to all 8 electrons. Remember, the goal here is to give each element an octet. Does this work? Yes, it does. Now, back to this point where we had 2 bonds on the left and 1 bond on the right. Remember, before what we did is we swung that pair up. But do we have to? Can we take this pair and swing it up instead? Yes, and that's what gives us a triple bond. This still works because oxygen on the left still has access to 8 electrons, carbon in the middle has access to 8 electrons, and oxygen on the right still has access to 8 electrons. Remember, this part is easy because we can see 2, 4, 6 electrons, but this part right here is still showing us 2 electrons, and oxygen, even though they're shared, still has access to both of those electrons. Now, the difference here is that in this picture, you see that the triple bond is on the left. On this side, you see that the triple bond is on the right. Those are 2 different structures. They're equivalent in that they have the same number and type of bonds, but we have to remember that those oxygens are technically different oxygen. If we call this oxygen 1 and oxygen 2, we're putting a triple bond on oxygen 1 in the first structure. In this picture, if this is still oxygen 1 and this is oxygen 2, we're putting a triple bond on oxygen 2. So they are different structures, but they are all acceptable Lewis structures for CO2. So resonance is what we call structures or compounds that can have more than one Lewis structure. So we have to maintain that these are oxygen 1 and 2 in each of these compounds. So you can see that each oxygen 1 has a different number of bonds. This has a single bond, this has a double bond, this has a triple bond. So these are all different structures, different possible resonance structures for CO2. One molecule, multiple Lewis structures. Now, this is a little bit different because what we're seeing here is this negative charge that we're adding to this compound. So remember, this is an example of a polyatomic that we're coming up with a Lewis structure for. Carbon is in column 4. It has access to 4 electrons. Nitrogen is in column 5. It has access to 5. What we do with this additional one is we have to remember that electrons carry a negative charge, and since we're determining how many electrons each element contributes to the overall structure, we have to add 1 in this case. The negative adds an electron to the total. So I have 4 plus 5 plus 1, which gives me a total of 10 electrons to distribute. There's only one way to set these up because I only have 2 elements. So I'm going to bond them, and that bond takes away 2, so that's going to give me 8 to work with at this point. I'm going to put 6 around nitrogen, 2 around carbon, and we can see that that creates a little bit of a problem. Nitrogen has its octet, carbon does not. Carbon only has access to 4 electrons in this case. So we need to swing one of those down to create a double bond. This still works for nitrogen because nitrogen has access to 8 electrons. Carbon now only has access to 6, so we need to swing down another pair. Remember, the whole reason this works is because nitrogen has access to both of those electrons in either case. Whether it's a lone pair or a bonding pair, nitrogen still has access to both of those. In this case, we can see that nitrogen has access to 8 electrons, and carbon also has access to 8 electrons. So this one does work because the octet rule is satisfied for both elements.